Not a valid operator? Is it NEQ? Wait, where's the browser? There it is. Operators. Not equal to. There it is. Less than is also good. But technically not equal to should work. And obviously we have to count plus plus here to increase the count. Oops, what am I doing? Visual. And I think the issue is that we don't have a count variable. Yeah, we don't have a count variable, so bash expands this to an empty string. So this whole while expression evaluates to while bracket empty string not equal to something. So this is effectively the same as while not equal blah blah blah. And that's why it's complaining about the unary operator, because a unary operator is an operator that acts on just one variable, which is not the case. So we have to give the count a value. I think this should work. And this is power. This is a power operation. So we compute the power of 2. Well, we compute 2 to the power of 8. Doesn't work. Why doesn't this work? Because we don't print out the results, obviously. We have to print out the results here. So let's try again. And it seems to work. We have our own power function and the result is correct, 256. What if we do 2 to the power of 16? That's 65,536. That's also definitely correct. What about 2 to the power of 3? 64. Okay. Wrapping this up, basically this is how you do basic integer operations, and you can do it to arbitrary complexity, obviously. But what if we want something a bit more sophisticated? For that we can use floating point operations using BC. According to this guide here, there's the data types section, and somewhere down here it says that data types are limited. Bash does not support floating point arithmetic natively. For such operations, consider using external tools like BC or AWK. So let's try to implement some floating point operation using BC, and that should be installed on any Linux system. BC is an arbitrary precision calculator language. And BC is a language that supports arbitrary precision numbers with interactive execution of statements. And are there any examples here? By the way, there are some similarities in the syntax to the C programming language, but which is quite convenient for us. So no new syntax that we have to learn. And we can the following expressions are supported. Minus expression is just a negation of an expression. Plus plus variable is an increment. etc. You all know that stuff. Expression plus expression is just the sum of two expressions. The division, modulo, exponentiation. Is it even called exponentiation? I don't know. No. Yeah, the first is raised to the second. It's the power operation. These are the parentheses to alter the standard precedence, etc., etc. And this is for floating point operations. We can even do the square root and some other stuff. But this looks very, very promising. It even has loops. Crazy. Whoa. It has loops. Okay. So let's see what we can do with it. I would say a nice floating point operation would be a let's compute the escape velocity of a planet. Escape velocity of a planet. And it should only depend on a single variable, which is the gravitational acceleration. So we can just compute the escape velocity. And by the way, for those who do not know, the escape velocity is the velocity at which something has to move in order to escape a planet's or, well, whatever mass's gravitational field. So if you want to shoot a rocket off Earth and you want it to escape Earth's orbit, then you have to accelerate it to the escape velocity. And of course, the bigger the gravitation on a planet, the bigger the escape velocity. For example, on Moon, the escape velocity is much, much smaller than on Earth. So there are two variants of the escape velocity. There's this first variant, which takes the gravitational constant into account and the mass of the planet, and the d should be the diameter. Is it, or is it? No, this is the distance from center, so it's the radius. Yeah, and there's the other variant, on which just requires the gravitational acceleration and the radius. I think for our case, the first variant would be more interesting because it takes two arguments, the mass and the radius, and the other one, the gravitational constant, is a fixed constant. So let's create a new function. Because that's something that we have to compute every day. We need to know the escape velocity of the different celestial objects every day. So that's why we should include it into our into our super powerful compute script. Our compute script is so useful. It now allows summing up numbers and calculating the power of something and the escape velocity. That's the most useful script ever. But let's try. Escape velocity of a, well, escape velocity. Let's just put it like this. Oops. So, escape velocity. If the function's name is called esqv, which is the escape velocity, then we perform a computation using BC, and now we have to find out how BC is used. So let's go to a new terminal and try it. So this is BC. It opens a shell, apparently, a subshell, and here we can just type stuff. Yeah, and that seems to work. Now, what happens if I do a floating point division? That doesn't work because that's okay. So it still seems to handle the numbers as integers. What if I do 6.0 divided by 7? Still 0. So let's see what's going on here. Float. If we search for precision. So BC is a language that supports arbitrary precision numbers, which is what we need. But do we have to set the precision somehow? I think somewhere we have to define the number of decimal digits, no? So let's have a look at a BC example. I don't think there's any example in this man page. Oh, there is? No, there's not. There is. This is an example for the BC language even. And here at the beginning of the script, it says scale 20, so that might be the okay. If BC is invoked with the -L option, a math library is preloaded and the default scale is set to 20. The math functions will calculate the results to the scale set at the time of their call. And the scale is the precision. Yeah, because BC scale max refers to the number of digits after the decimal point is limited to blah, 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 blah. Okay, but that should be the precision. That's fine. So let's try to set scale to 20. And let's do 7 divided by 8. And as you can see now, we have a floating point operation with 20 digits of accuracy. We can even do scale 100. And then let's do something like 7 divided by 6. And that gives us 100 decimal digits. So we can have arbitrary accuracy here. That's good. And if we use BC-L, we get 20 digits of scale by default. So let's BC-L, and without setting anything, let's try 6 divided by 5. And as you can see, we have floating point operations here. Okay, now BC-L is running in an interactive mode. I don't want that. I want to use it from the command line directly because I want to script it here to compute the escape velocity for our small little program. Let's try to find out how that's done. Maybe standard in. Wait, it must use standard in because BC-L is now listening on standard in for some computation, for some request, and then printing the result to standard out. So we can definitely do BC-L, and then we can echo something into that. 5 divided by 7. Pipe that into BC-L, and let's see what the result says, and we get the result like this. So that's perfect. That means to compute the escape velocity, we can create a variable, escape velocity. Let's do it. Let's call it vescape. That's more academic. So vescape, the velocity of escape is equal to the square root of something. And now we have to somehow use bc-l, and I think we need to evaluate the function here somehow. How do we do it? I think we need to do this. And now we can do that. So this is a function evaluation as far as I know. I might be wrong, however. No, I have to look it up. So let's go back to the bash tutorial. Bash operators, bash functions. How about bash script? No. Wait, bash evaluate function in variable. Maybe something like that. I'm not sure. Let's just try something. So no, I have to look up the syntax with the parentheses and all that stuff. I was not sure about that. If else functions, loops, arrays, script syntax, maybe. Bash parentheses, curly braces. Parentheses cause the commands to be run in a subshell. Braces cause the commands to be grouped together but not in a subshell. I don't think that's relevant right now. What if I do vescape is equal to bc-l, and then I just type the command as I would. Let's just do 5 + 1. Pipe that into bc-l and see if that puts the result into vescape. Maybe I have to group the commands together using the parentheses here. I'm not sure. Apparently this piping, the pipe operator does not work here. What we could do as a workaround would be this and then vescape, and we give that the return value of the previous function. I forgot what the special variable for that was. I don't know exactly. Bash get function return value. No idea. What happens if I just execute that now? So escape velocity, and let's say we provide the values 5 and 7. We get a result 6 and it says no computation performed. That's because we haven't exited here. And now we get the result 6, which is 5 + 1 piped into BC. So that seems to be working. Yeah, that seems to be working. So that outputs the result directly to the standard out. So that's actually already fine. Of course, it would be somehow nice to create a variable escape velocity and then echo that ourselves, but this is also fine. And now we can perform an actual computation. Let's echo square root, and let's pull up the formula for escape velocity again. square root of 2 multiplied by the gravitational constant, which is this. Two multiplied with the gravitational constant. I'll give this a variable, a constant variable input here, multiplied with the mass divided by the radius, multiplied by mass divided by the radius. And then we can assign those variables here. G is the gravitational constant. 6.67 multiplied with... we can just give it a string value. I think 6.67 multiplied with 10 to the power of minus 11. And the mass is the first input argument. And the radius is the second input argument. Put in a string. I think that might work. Let's try. And if we compute, oops, as you can see, we get a result, and that is an incredibly small input velocity, because the mass that we input and the radius are both very small, 5 kilograms and 7 meters of radius. So that's an incredibly light planet, which won't work. And here's the interesting part. Now we can even specify very, very large values. So let's input the Earth's mass, Earth mass, 5.972 multiplied with 10 to the power of 24. So let's do 5.972 multiplied with 10 to the power of 24. And the radius is, I know the Earth is not a perfect sphere, but the radius is approximately 6,378. 6,738 kilometers, so multiplied by 10 to the power of 3 meters. And let's see if our compute script is now able to put all of that into the BC process and perform a valid computation, perform a working computation. Let's see. And we have a result. This is allegedly the escape velocity in meters per second. So in SI units. We could technically also return it in... Well, it depends on what you want to do with your program. We can do this. We can echo the result in meters per second. Let's try to do that. I have to find out how to evaluate a function in a string. Evaluate function in string bash. Maybe let's do it simpler. That's confusing. Without obfuscating the syntax ourselves. Let's do the following. We compute the escape velocity here and put that result into a variable. Oh no, this doesn't make it easier. Evaluate string expression. What if we do this? Does this work? Oh, this might work. The syntax might work for evaluating functions. Let's put that in a string and let's echo that string. And here we can now attach something. We can attach the unit here, meters per second. If that works, I'll freak out. Doesn't work. Obviously, it doesn't work. Doesn't work. Obviously, it doesn't work. Syntax error. Oops. Probably that's because the -l in the parentheses cannot be separated out by bash. So let's give this a bit of space. Let's see if it works now. No, it doesn't work. Ah, damn it. That would be super nice. No, Google is misunderstanding me. I want to evaluate this function and store the result in a variable. How hard can it be? Bash store results of command in variable. Oh, that's probably very simple. It's that. Do I have to use single parentheses? That might work. Yes, that works. Awesome. Super awesome. So let's try. And as you can see, we now have a computation that outputs the escape velocity together with a unit, meters per second. But we can also output that result. We can convert that result into kilometers per second or per hour, which is more useful. So let's do escape and give this the variable value. This. So this is the value of that command, the escape velocity in SI units. Now, to output it in meters per second, all I do is I reference that variable here because it is already in meters per second, and I print it to the console like such. Now, if I want to convert it, I can do vesc in kilometers per hour, and let's convert that, and that is equal to v escape echo. We have to echo v escape into bc and divide it by 3.6, I think. Because 100 kilometers per hour would be 36 meters per second. Could that be? No, what am I talking? Something like 30 meters per second. Yeah, so we have to divide. So we echo the value of v escape into bc dash L. And then we output v escape kilometers per hour here, kilometers per hour, just like so. And the escape velocity would need to be divided by 3.6. I think it's, you have to do it like this, and then this quote has to be removed. And I think now it's fine. So we're taking that result, dividing it by 3.6 and echoing it into bc-l, and then storing the result in kmh, and then echoing that as well to the console. Let's see if that works. And we now have the escape velocity in kilometers per hour as well, but this is a ridiculously high number. This is impossible. It's impossible that this is correct. 3 million kilometers per hour. No, this cannot be correct. So there is definitely an error somewhere. Either it's in the mass I provide here, or in the radius. So either it's in the provided values or it's in the computation. Now we have to figure it out. So the radius of Earth is 6,378 kilometers. We can also just write that to the console. Echo no, but, well, we are providing those as inputs. I'm wondering why the R is not syntax highlighted here. So echo Earth, or mass is, can I just do this? Radius is this. I don't know if that works or if I have to provide curly braces. Apparently I don't have to. So let's clear again and see the result. So mass is this. So this seems to be correct. And this seems also to be correct. Now, Earth mass 5.972 multiplied with 10 to the power of 24 kilograms. That should be fine. That means that the issue is more likely in our computation. Let's look up the escape velocity again. We take the square root over 2gm divided by d. Square root over all of that. 2 multiplied with g multiplied with m divided by g. I think an issue could be that I provide the quotes here, which probably I shouldn't, because those would be misunderstood by BC as some ASCII characters, which probably also have values. I don't know. Let's try. If we, for example, write to the console 5.972 multiplied with 10 to the power of 24, what's the result? It's this, which seems to be correct. What if I do the same thing but in quotes? Yeah, that evaluates just to the string. So this is not a mathematic expression. This is just a string. And BC can't handle this. So we should strip our inputs from the quotes. And now I would expect correct values to be computed. So the mass is this, radius is this. We can even provide units here. For that, we have to probably put the mass in curly braces. And that seems to be what the curly braces are for. So let's try again. Compute escape velocity of that, and let's try. And the result is that's very, very fast. This cannot be correct. And by the way, the result is the same as before. And I think that is because I put my variables in quotes as well, which may not be desired. So maybe it makes sense to store the expression here in an expression variable. Then we can echo the expression into BC, and the expression itself, we can echo that to the terminal as well. Expression to be evaluated is expression. So let's see if that works. Yeah, and the expression to be evaluated looks correct. I know why. That's because the expression to be evaluated now breaks the precedence, because I am expecting the precedence to be evaluated as in this expression string here. But since the variables are expanded and they are now since the variables are now expanded, the division acts on this 6,728 only, and then the multiplication here multiplies the entire result of that. So this is evaluated first, and then this multiplication is appended afterwards, is evaluated afterwards. So what we have to do is we have to make sure that everything here is put into parentheses for proper precedence. I think this first line of, well, the numerator doesn't need to be put in the parentheses. It's just the denominator should be. Well, but okay, God knows what people will input here in G and M. If they input other complex computations with sums, then this will break precedence. So this should be fine. If we want to make it extra sure that everything is correct, we should even put the individual variables in parentheses. Just like this. And let's try to compute. And we get a result. So the escape velocity is 10,800 meters per second, which is 3,022 kilometers per hour. Let's confirm that online. Earth escape velocity in kilometers per hour is 40,000 kilometers per hour. Ah, I know why. I have to multiply with 3.6 and not divide by 3.6. Okay, let's try again. And yeah, there we go. So it's approximately, according to this guide, 11.2 kilometers per second. And 40,000 kilometers per hour. I think this is adequately precise. That depends, of course, on the values input into the computation. So we found that it is 10,800 meters per second or 39,000 kilometers per hour. I don't know which values this AI overview here used. Yeah, I think it's just a difference in the values provided to the computation, although it bugs me a bit that it's not exactly the same. Maybe we have to refine the G. So the universal gravitational constant is this, and it is 6.67430. What's the difference between those two? 6.6743. So this should be more precise now. And aside from that, which radius is used in those computations? Earth escape velocity. And they used a mass of 5.9736. 9736. I also used a different value here. 9736. And a radius of 6,371. 6,300? Oh, I have mixed up the numbers here, I think. 371. Okay, let's compute. And now we have the accurate numbers. So we have the result that the escape velocity is 11,000 meters per second, which is 40,000 kilometers per hour, which is ridiculously fast. And that matches roughly what we see here. Here it says 11,186. And we have 11,187. Awesome. That's good enough. Depends on precisely which values were input into the computation. Okay, I think that's enough for this video. Now you know. And I found it quite interesting because we use such a non-traditional way of computing stuff. But it's quite powerful because it's all possible in Bash. And every single Linux machine on the planet runs Bash. So you can generate your own script to calculate anything, whether it's just plain integer computations with some function or with some process results, whatever. Of course, these were super dumbed down examples, just summing up numbers or computing the power of something. But you can also create more advanced calculations, for example, here for the escape velocity of some celestial body, and have a result computed for you in Bash. And it's super powerful because you can create your own script that contains computations that you use frequently. I don't know what you study as a major, but if you're a physics major, for example, or a math major, or whatever, engineering major, there are some things that you frequently compute, and you can just create your own calculator that way. Give it make it support a couple of different functions. For example, escape velocity, whatever, acceleration times, free fall, ballistic curve. I don't know. It doesn't even need to be just physics. It can be anything. Computations about time passed for something. You can do anything. Anything you compute occasionally. And you cannot do it all in Bash. And even though nobody ever uses Bash for computing stuff, I find it quite nice to have looked into how it works. And even though I just wanted to look into crunching numbers in Bash, we have also learned quite a bit about the syntax, the if-then statements, while loops, for loops, these special arguments here. So this was quite interesting. If you also found it interesting, then stick around and see you next time. Bye.